Electrolytic cell. Electrolysis is a non-spontaneous redox reaction, means reducing and oxidizing, or reduction or oxidation reaction is made to occur by supplying electrical energy to the system. Electrolytic cell is an electrochemical cell that undergoes a redox reaction when electrical energy is applied. Consists of two electrodes, on the left anode and on the right cathode, immersed in an electrolyte. The solution here we call electrolyte, and connected to a source of direct current. So this can be batteries. And this is ammeter to measure the electric charge. Electrons flow from anode, so electron flow from anode to cathode. Note that here anode is positive electrode. In galvanic cell previously, anode is negative electrode, so it is opposite in electrolytic cell. Anode is positive electrode. Electrodes are conductors which oxidation or reduction occurs. So here is where oxidation and reduction occurs, at the anode and at the cathode. Inert or inactive electrodes, for example platinum or graphite, so here anode and cathode, usually inactive or inert since they do not react with the electrolyte. Electrolyte is a liquid that conducts electricity due to presence of positive and negative ions. So in this electrolyte consists of positive and negative ions. Electrolyte must be in molten state or aqueous solution so that the ions can move freely. Because ions need to move freely in order to conduct electricity. That's why electrolyte must be in molten or aqueous state. Direct current source supply electrical energy to force the reaction to occur. So this here, direct current source supply electrical energy for this reaction to occur. Oxidation occurs at the anode. Here, anode oxidation, same like galvanic cell. At the anode, oxidation occurs means it is losing electron. So negative ions attracted to the anode. Since this oxidation occurs here, so negative ion attracted to the anode. Because anode is positive electrode, so negative ions attracted to the anode. Reduction occurs at the cathode, means at the cathode it gains electron. If it gains electron, the cation or the positive ion in the electrolyte attracted to the cathode. Electron travels through the wire here from the anode, positive electrode, to the cathode, negative electrode. So that's why the electron flow and receive, the electron received at the cathode means cathode gain electrons. Ions are said to be discharged at the electrodes. There are three factors affecting the products of electrolysis. The first factor is standard reduction or electrode potential of the species. Second, concentration of the species and the nature of electrodes. Standard reduction or electrode potential of species. At the cathode, reduction occurs. At the cathode, reduction occurs when E0 is more positive. So E0 more positive refer to standard reduction potential table. If the E0 is more positive, E0 value more positive, reduction will occur. It will occur at the cathode. And if the E0 value in standard reduction potential table is more negative, oxidation will occur at the anode. So this is the example of standard reduction potential table at 25 degrees Celsius, or this value here. The more positive reduction will occur, more negative value oxidation will occur. So this is electrochemical series for ions. Then molten salt. We have electrolysis of molten salt, for example, sodium chloride. We have electrolysis of water. We also have electrolysis of dilute salt, for example, sodium chloride. So the difference between molten and dilute: in molten there is no water. In dilute there is presence of water. Electrolysis of molten salt, for example, sodium chloride salt. Here, this is the electrolysis of sodium chloride. You have the battery, anode and cathode electrode. Both electrodes are inert, means the electrode does not react with the ions in the electrolyte. It does not react in the reaction. That is inert electron means. So here in molten salt, it only contains sodium ion and chloride ion. Okay, cation Na+, and ion Cl-. No water in molten salt. It requires high temperature due to its strong ionic bond. For this to be molten, it needs high temperature because the ionic bond between Na and Cl is very strong. We know that at the anode, oxidation will occur. At the cathode, reduction will occur. So here, the Cl- in the electrolyte will be attracted to anode, and the Cl- will lose its electron to become Cl2. Here what it means by oxidation occur at the anode. Negative charge attracted to the anode, and then the negative charge will release the electron to become here chlorine gas. So oxidation reaction at the anode. And then the electron travels from the anode to the cathode. The cathode here received electron or gained electron. So here reduction will occur. Because at the cathode here, when there is electron at the cathode, the positively charged ion will be attracted to the cathode. So this positively charged ion attracted to the cathode due to the presence of electron here, and the electron will neutralize the charge to become an A. Liquid plus Cl2 gas. Okay, there's no aqueous here because aqueous when the presence of water. So there's no water, state of matter cannot be aqueous. At the cathode, Na+ attracted to the cathode because the Na+ will receive electrons from the anode, receive electron, neutralize to become Na liquid. Means you will have Na liquid around the cathode. Sodium is deposited at the cathode. Here, chlorine gas will be evolved at the anode because Cl- become Cl2, and that Na+ receive electron becomes Na. This is what happened in electrolysis of molten salt. In water, water is an electroactive substance that may be oxidized or reduced in the process. We know in water we have OH- and H+ in water. Water is not a good conductor, means it does not carry a charge very well. So you need to add dilute acid a bit is added to the water. So dilute acid is added a bit into the water for electrolysis of water. At the anode, here at the anode, oxidation will occur, and at the cathode, reduction will occur. So at the anode, if oxidation reaction, the water will lose electron. When it loses electron, the products are oxygen gas and H plus aqueous. So for oxidation of anode, oxidation of water, because we only have water here in the electrolyte water, so oxidation of water result in oxygen gas and H plus ion because electron is removed. And at the cathode, reduction. At the cathode, reduction reaction. Reduction means gains electron, so this water gains electron, 2 electrons, and it will produce H2 gas and OH minus aqueous. Since we have H plus at the anode, so the solution around the anode becomes acidic because the production of H plus at the anode. Since there are production of H2 and OH minus, here H2 and OH minus at the cathode, so the solution around cathode become basics due to the presence of OH minus. So around cathode it becomes basic, around anode it becomes acidic. Overall equation, 2H2 liquid water produce hydrogen gas and oxygen gas. Cancel out the electron, so the cathode equation must times by 2 to make the electron 4 here. Cancel out and you'll get this overall equation. Next, electrolysis of dilute aqueous salt. Contains, here aqueous means there is a presence of water. Contains Na plus, Cl minus and water in dilute aqueous salt. So we have to compare various electrode potential to predict the electrode product because we have more than one cations and anions. So you have to choose which one will be at the cathode, which one will be at the anode. First thing first, we know oxidation at the anode, cathode reduction. So at the anode, oxidation, it means the electron is loose. Reduction, electron is gained. And at the anode attract Cl minus ion because this Cl minus will produce Cl2. Okay, oxidation, Cl minus becomes Cl2. And then water molecule, we have water molecule for oxidation. Water molecule, it will lose electron and the product will be H plus and oxygen. At the cathode, reduction. So reduction will happen at the cathode, so means it will gain electron. When it will gain electron means it attracts Na plus. Na plus will be attracted to the cathode. For this Na plus to become Na, neutralize the plus here, it becomes Na, it will gain electron. And then H2O molecule, if reduction H2O molecule, it will gain electron producing hydrogen gas and OH minus. So you have to choose which one will be attracted to the anode, which one will be attracted to the cathode, because we have two here at each cathode and anode. You cannot attract both, only one. So how to choose which one? Look at the electrode potential value. So for Cl, electrode potential value plus 1.36 volt. For water that has oxygen and H plus, because water we have two. In the standard reduction potential table, you have two equations for water. One water that will produce oxygen and H plus, another one water that will produce H2 and OH minus. So at the anode, we know that at the anode, oxidation will occur. So oxidation means lose electron. Lose electron, water will produce H plus and O2. So compare with this one. So compare these two values, which one to choose, H2O or Cl minus. Anode, we prefer the more electronegative value. More electronegative value, more negative value. So it is E naught equal positive 1.23. Water is chosen to be attracted to the anode, mean water here will undergo oxidation at the anode, not Cl minus water, because the value of E naught cell for water is more negative than the Cl value. So water is chosen. This is the equation. H2O release oxygen gas and 4H+. This oxidation will occur at the anode. At the cathode, you have Na or water. You have to choose between these two. So, cathode reduction, we look at the more positive value. Refer to the electrode potential for Na and water. More positive value goes to water. Negative 0.83 compare with negative 2.71. More positive for water, so water is chosen. Cathode reduction, write the reduction equation for water. H2O liquid plus electron, it will produce hydrogen gas and OH minus. Cell reaction, so cell reaction, half cell between these two, half cell equation, and then if you combine these two together, cancel out the electron, this equation times 2 to make this electron 4, and then you can cancel out here 4 and 4, and then this is the overall cell equation. And if you look at the back, at the product side, you will have 4OH minus aqueous plus 4H plus aqueous. If OH minus plus H plus, it will become H2O. Since we have these two 4, you will have 4H2O. So this 4H2O cancel out with the H2O at the front, 6. Cancel out here 4, cancel out here 4. You will have another 2 water because you cancel 4 here, 2 water producing oxygen and hydrogen. This is the final overall equation for electrolysis of dilute aqueous salt using NaCl. Okay, for dilute aqueous, you have more than one products at the anode and cathode, so you have to choose which one by looking at the electrode potential. Next factor, concentration of species. It influences in the discharge of anion only. Concentration, look at the discharge of anion, the negative charge. High concentration of the negative charge will be discharged. We ignore the electrode potential value. If it is concentrated, if the concentration is high for anion, if concentration of anion is high, ignore comparison for electrode potential like this. This one, dilute, we have to take account the electrode potential. For here, more negative anode, here more positive cathode. That's for dilute. But if it is high concentration, especially for anion, so you ignore the electrode potential value, choose the one that which has high concentration. That will be produced at the anode or cathode. Okay, so for example, OH minus is preferred to be discharged compared to Cl minus according to electrochemical series. So according to the value standard reduction potential table, OH minus will be discharged compared to Cl. Okay, OH minus will be discharged compared to Cl if you refer to the electrochemical series to the value. But Cl minus will be discharged. This is because Cl minus concentration is high. That's the second factor, concentration of the species. Electrolysis of concentrated NaCl. This one dilute. You have to look at the electrode potential value to know which one will be produced at the anode and cathode. But for concentrated, choose the high concentration anion. Okay, in concentrated NaCl, we still have Na plus, Cl minus, and water. But in concentrated solution, we don't have to compare the electrode potential. Choose the anion that will be discharged, that will be oxidized because it has high concentration. Okay, if you look at here, anode oxidation in the electrolyte you have NaCl. So anode oxidation means oxidation will occur at the anode. Water undergo oxidation, Cl minus undergo oxidation. So both of these undergo oxidation, water and Cl minus. Water oxidation, it will produce H plus and oxygen gas. Cl minus, it will lose electrons to become Cl2. Okay, which one to choose? Compare these two electrode potential. More negative will be chosen, water will be chosen, but here we don't choose water. Even though this is more electronegative, because more electronegative will be chosen at the anode. Even though water is more electronegative, it will not be chosen because the concentrated NaCl, anion with high concentration will be chosen, which is this one. So Cl minus will be attracted to the anode compared to water. Water will not be attracted to anode. Cl minus will undergo oxidation at the anode to produce Cl2 plus 2 electron. So this one will undergo the oxidation, Cl minus. At the cathode, reduction, so you have to choose between Na plus and water. Choose between Na plus and water. We choose, for this one, cation and then water. At the cathode reduction, for water, reduction means it will gain electron. Water gain electron to produce OH minus and hydrogen gas. And Na plus undergo reduction, it will receive the electron, it will gain electron. Na plus gain electron to become Na. Okay, at the cathode, we have to choose more positive electrode potential value. More positive electrode potential value means we will choose water. Okay, this is concentrated. We will choose the high concentration of anion. This is cation, so we don't choose Na because Na is cation. We only choose high concentration of anion. So this one, Cl minus will be chosen to undergo oxidation, but this one, it follows the electrode potential value. For cation and water, when you compare cation and water, it will follow electrode potential value. Means the water will be reduced at the cathode. Water receive electrons and it will produce hydrogen gas and OH minus. So combine this equation, half cell equation, to make it overall equation. Cancel out 2 electron and your overall equation will be 2H2O plus 2Cl minus to produce hydrogen gas and Cl2 gas and OH minus aqueous. This is the overall equation for concentrated NaCl. We choose the high concentration of anion. We don't have to compare the electrode potential for the anion because anion has high concentration. That's the second factor. The third factor, we look at the nature of electrodes. Nature of electrodes affects the ion selected to be discharged at the electrodes. So, the nature affects the ion selected. Inert electrodes, for example graphite or platinum, normally used in electrolysis. We usually use inert electrode because they don't involve in the reaction. For electrolysis, usually use these two. But we can also use active electrode. Active electrode such as metal anode will dissolve to form metallic ions if the electrolyte contains ions of the same metal. So if we have active electrode, we will choose that ion. We don't have to compare the value, electrode potential value. Choose that electrode. For the reaction to occur, we choose that active electrode if in the electrolysis have active electrode. Okay, now comparison between inert and active electrode. So if in inert, both electrodes are inert, so in the electrolysis of copper sulfate aqueous solution, so for example, we use copper sulfate aqueous solution. In the electrolysis, anode water will be chosen, cathode Cu2 plus will be chosen. These two depends on the electrode potential value. At the anode, we compare between water and SO42 minus. Compare between water and SO42 minus because we know anode oxidation, so we compare water or SO42 minus. Compare the electrode potential value, and then for water will be more negative value, so that's why we choose water at the anode. At the cathode, we compare between Cu2 plus and water, but then at the cathode it must be more positive value of electrode potential. So more positive value of electrode potential goes to Cu2 plus compared with water. So that's why we choose Cu2 plus to be reduced at the cathode. And then this is the overall redox reaction. That's for inerts at both electrodes. But if you have one active electrode, for example, you use copper electrode because our electrolyte is copper to sulfate. Our electrolyte is copper to sulfate. And then you use the electrode which is the same as the electrolyte. Here copper to sulfate, electrode you use copper, same. So same active electrode, same with electrolyte. When you compare the reduction potential, electrode potential value, water and the copper, water is more electronegative, more negative value for water, more negative. We're supposed to choose water at the anode, but we are using active electrode which is the same as the electrolyte. So we don't choose water, we choose the electrode, we choose that active electrode. So that active electrode will undergo oxidation at the anode. At the cathode, compare Cu2 plus with water, and Cu2 plus value for electrode potential more positive, so that's why we choose Cu2 plus. Okay, this one we don't consider at the anode. We ignore the comparison of electrode potential value because we have active electrode at the anode. So we choose that active electrode. This is the overall redox equation. Copper is transferred from anode to cathode through solution Cu2 plus. The concentration of CuSO4 remains unchanged. Even though the electrode, solid copper electrode, undergoes oxidation to become Cu2 plus, means the copper is transferred to solution, the concentration of CuSO4 remains unchanged. Look at here. These two, the comparison that I made before, we use two same inert or inactive electrode, platinum. Okay, both platinum, and we have CuSO4 electrolyte. In the electrolyte, we have Cu2 plus and SO42 minus. Okay, in the electrolyte, you have Cu2 plus, SO4 2 minus, and you also have water. At the anode here, water and SO4 2 minus is attracted at the anode. But which one will be chosen? It depends on the electrode potential value. Okay, if you use inert both electrode, the one that will be chosen depends on the electrode potential value. But if you put active electrode here, you put copper anode. You put copper anode here. Okay, you put copper anode, and you have the same electrolyte that have the same ion, electrolyte copper sulfate electrolyte. So this active electrode will be chosen. The ion of active electrode will be chosen to undergo oxidation. Because the anode, you use the electrode that has the same ion as the electrolyte. That's what it means by factor nature of electrode. Nature of electrode, active electrode will dissolve to form metallic ion if the electrolyte contains same ion of the metal active electrode. Okay, we ignore the electrode potential value, we choose the active electrode. Uses of electrolysis. It can be used for electroplating and purification of copper. Electroplating is a process of a thin coat of metal is applied to an object in a solution containing the metal ions, passing an electric current through, causing metal to be deposited on the object. Means you have thin coat of metal applied to an object in the solution. That solution contain the metal of the applied metal. That solution contain the metal, same metal of the applied metal, and you pass electric current, making the metal to be deposited on the object. Means the solution here will be deposited on the object. I'll show you in details the electroplating on the slide later. Second uses purification of copper or any types of anything that you want to purify. Here copper, so pure copper is extracted from copper ore. Copper ore means copper mixed with impurities. Okay, copper ore means copper that has impurities in there. If you want to remove the impurities in the copper ore, you undergo purification of copper by using electrolysis. How? Passing an electric current through solution containing copper compounds. Use the solution, the electrolyte that has copper in there. That's how you produce pure copper, by remove the impurities in the copper ore. Okay, first, let's take a look at the first uses of electrolysis, which is electroplating. Electroplating is, you have an object, you want to coat that object using that kind of metal. For example, we have a key, you want to coat the key here using copper. Coat the key using copper. That's what we call electroplating. You put the thin coat on the desired object. So at the anode, the positive electrode at the anode, you put the coating metal, the one that you want to coat with, the coating metal. Here, we put the copper metal because we want to coat the key using copper. So we put the copper metal at the anode. At the cathode, negative electrode, put the desired object to be coated. That is how you do electroplating. So we know at the anode, oxidation will occur. So the copper solid, oxidation will occur. The copper solid will lose its electron to become Cu2 plus. So the solid will become Cu2 plus ions, losing electron. So that's why this copper metal becomes thinner and thinner, because you keep converting this metal to become Cu2 plus. That what will happen at the anode. And then electron flow gained by the cathode. The key here, gained by the cathode. So at the cathode, in this solution, we use the copper sulfate solution. We use the solution that has the ion for the coating metal. In the solution, the Cu2 plus product from the oxidation just now, the product Cu2 plus of the oxidation just now, that Cu2 plus will attract it at the cathode and it will gain electron at the cathode. It will gain electron and the Cu2 plus will become Cu metal, Cu solid. It will deposit it around the key. The Cu solid will deposit it around the key. That's what will happen at the cathode. Gain electron, product is Cu solid. Next, the second uses of electrolysis is purification of copper. You have copper ore, you have impure copper. You want to make it pure copper. Okay? At the anode, at the positive electrode, you put the impure copper. At the cathode, you put the pure copper. Okay? Now you want to collect the pure copper from impure. You want to remove impurities. You want to collect the pure copper only. Okay, so here, anode, we know that at the anode, oxidation means it will lose electron. So copper solid here will lose electron to become Cu2 plus. Copper solid lose electron to become Cu2 plus. Cu2 plus will dissolve in the electrolyte here. It will become ion in the electrolyte here, Cu2 plus. And the electron release, so impurities will be left here. Impurities left because it's not involved in here. Only oxidation reaction involved here. And then the electron is transferred. That electron will gain at the cathode. Okay, cathode will receive electron. What happened to the electron that is received at the cathode? Previously, you have Cu2 plus product. From the oxidation, you have Cu2 plus product. That Cu2 plus product will receive electron at the cathode. It will receive electron, it will gain electron, Cu2 plus gain electron, it will become Cu solid at the cathode. So you will collect pure copper at the cathode and the impurities will be left under the anode. Okay, so at the cathode, only pure copper. This is purification of copper. The difference between Voltaic cell or galvanic cell versus electrolytic cell. Voltaic cell, we don't use battery. The reaction is spontaneous because it's from chemical energy to electrical energy. A galvanic cell, chemical energy to electrical energy. But electrolytic cell, we use battery. We supply electrical energy for the reaction to happen. That's electrolytic cell. And electron is generated, means electron is released at the anode. In voltaic cell, electron is released at the anode. Voltaic cell, electrolytic cell, electron removed from the anode. Same, both is the source of electron, but the charge are different. Anode in voltaic negative. Anode in the electrolysis, positive. In voltaic cell, electron is consumed at the cathode, electron received at the cathode, but your cathode is positive in voltaic cell. In electrolytic cell, cathode is negative. And electron flow from anode to cathode for both, electron flow, anode and cathode for both voltaic cell and electrolytic cell. But note that anode is negative electrode in voltaic, anode positive electrode in electrolytic cell. Okay, vice versa for cathode. Next, Faraday's law of electrolysis. It is the relationship between amount of electricity. Faraday's law shows the relationship between amount of electricity passed through electrolytic cell and amount of substance produced at the electrode. You can calculate how much electricity passed through, how much product produced at the electrode by using Faraday's law of electrolysis. Amount of substance produced at each electrode directly proportional to the quantity of charge flowing through the cell. Means when you have bigger quantity of charge flowing through the cell, you will have bigger amount of substance produced at the electrode. Okay, so mass of substance discharged is directly proportional to electric charge, quantity of charge flow through the cell. This Q unit coulombs, C. And then Q, we know that Q is equal to IT. I is the current in ampere unit, time must be in second. Q, the charge can be calculated when you have the value of current and times. Charge can be calculated. Q is electric charge. Unit for Q is coulomb, unit for current ampere, unit for time second. Quantity of electricity is often given in terms of Faraday's constant. What is Faraday's constant? 1 Faraday equals to 1 mole electron. 1 mole electron equals 1 Faraday. It is equal to 96,500 coulomb. This is the electric charge. Okay, this is the value of Q. 1 Faraday, value of Q, 96,500 coulomb. This is Faraday's constant. Faraday law, this one, relationship between amount electricity passed through, amount of substance produced. This is Faraday's law. And the constant is 1 Faraday equals to 96,500 coulomb. It is equivalent to 1 mole electron. For example, we have aqueous solution copper sulfate electrolyzed using current. You have the value of I and time 5 hours. Note that time must be in second. These 5 hours you must convert to second. Calculate the mass of copper deposited. So we need to calculate the mass of copper deposited at the cathode. Now we have I and T. You can calculate Q because Q is equal to IT. I 0.15 ampere, T is 5 hours times 60 times 60 to get in second. So the value of Q equals 2,700 coulomb. Okay, here you have 2,700 coulomb. We need to calculate the mass of copper deposited when we use 2,700 coulomb. Okay, at the cathode, we know that at the cathode reduction means gain electron. So, gain electron, the cation will gain electron, Cu2 plus, gain electron to become Cu solid. From this equation, you know that we use 2 mole of electron at the cathode. 2 mole electron at the cathode means 2 Faradays. 2 Faradays, 96,500 for 1 Faradays times by 2 because we have 2 Faradays here. So If 2 mole electron, it will use 193,000 coulomb. That's for 2 electron. Okay, for 2 electron at the cathode, 2 mole of electron, this amount of coulomb. But we only have 2,700 coulomb. Is 1 mole of copper here, 1 mole copper, 2 electron. Okay, 1 mole copper here, 1 mole copper, 2 electron. That's why you have 193. If 1 mole copper, 193,000 coulomb, 2,700 coulomb, cross multiplication, you will get 0.01399 mole copper. From the number of mole of copper that you have, you can calculate the mass of copper when you use 2,700 coulomb. Mole convert to mass, you have to times with the molar mass of copper, 63.5 gram per mole, and the mass of copper deposited using 2,700 coulomb is 0.8884 gram. Okay, so this one you get from the one that we use, this amount of Q, because we only have this amount of Q. We don't have this amount of Q. This amount of Q is for 2 mole electron, 1 mole copper. We don't have 1 mole copper. We only have 0.01399 mole copper. Compare and use cross multiplication, and you will get the mass of copper deposited. Thank you.